Hi, today is May 27, 2024. In this time, we're going to talking about algebra. We're going to continue talk about quadratic function. So, for instance, if I give you a function as x squared plus 2x plus 1, we want to draw this graph. So we can rewrite this as the following: as x plus 1 squared. The reason I get that correctly, because I got it from the formula called a plus b squared equal to a squared, the first element square, plus 2ab, 2 times the element, and then plus b squared. Similarly, if we have a subtract b squared, it will be a squared subtract 2ab plus b squared. How do we get this? Because a plus b squared is equal to a plus b times a plus b. And then use this element times each of the element right here. That will have a times a plus a times b. Now you use the second element times each element of the second parenthesis. So that will be b times a, b times b, which is later on we're going to simplify. Due to the commutative law, a times b is the same as the b times a, and then a times a is a squared. Since those two are the same, we got a 2ab and then b squared. So the subtraction is going to be the same thing. I'm not going to repeat myself. Okay, so that we actually need to rewrite them as x subtract negative 1. Because when you subtract a negative number, it's the same as the plus the positive number. So those two are identical. Why we need a change to this? Because for the quadratic equation, the vertex form is like the following. Alright? So this one actually corresponding to x equal to a, and this is the symmetric axis. I saw so many students, they actually consider the symmetric of the axis is x equal to 1. Actually, that's x equal to negative 1. So you need to convert this to negative. What does that mean? Let's draw the graph x, y. Okay. X, O, y. So first, since we already know this is the symmetry of the axis, we know the graph is going to be, this is x equal to negative 1. It's going to be symmetric about this axis, right? So we know right here it's going to be the bottom point. So x equal to negative 1. And then we plug in right here. So y will be x subtract negative 1 squared. Will be negative 1 subtract negative 1 squared. Negative 1 subtract negative 1 equal to 0 squared, that equal to 0. And then we pick up x equal to 0. When x equal to 0, y equal to 0 subtract negative 1 squared. So that would be 1 squared equal to 1. So it's right here. Without even do it, we actually know when x equal to negative 2, that point got to be here. Let's double confirm that. When x equal to negative 2, y equal to, again, use this negative 2, subtract negative 1 square. So that would be negative 1 square equal to 1. So again, it is agreed. And then when x equal to 1, y equal to, again, plug in right here, is 1 subtract negative 1 square. So that's 2 square, that equal to 4. 2, 3, 4. So it's point right here. Okay, so when x equal to negative 3, due to the symmetry, we know it's got to be 4, but let's double confirm it. So it's y equal to x, which is negative 3, subtract negative 1 square. So that's negative 2 square. That's 4. So 4, it would be someone right here. So if we connect all those points, we will have the graph look like that. Okay, so now we're going to change this a little bit. How are we going to change it? See, this is the something we already been given, right? So in order to make a new problem, I just make this a little bit. I will set a new y equal to x squared plus 2x. Instead of plus 1, I say plus 2. The reason I'm doing that because I can further break down this equals that, like that, because 1 plus 1 equal to 2. And then this is the one we just graphed it. So that equal to x plus 1 squared plus 1. Now we try to working at this part, the b part, right? So let's look at it. This is xy, this is new xy. This part right here is this table. But this, the only thing, the only difference between this one and this one is because we add an additional one. In other words, for the same set of the x value, the y value will be 1 larger than what we had right here. So in other words, what we have is 1, because 0 plus 1 equal to 1. And then when x equal to 0, 1 plus 1 equal to 2. So on and so forth, when x equal to negative 2, we got 1 plus 1 equal to 2. When x equal to 1, we got 1 plus 4 equal to 5. When x equal to negative 3, we got 4 plus 1 is 5. Now let's graph this. Okay. So if this is the negative 1, we got a 1 right here, so it's right here. When x equals 0, we got a 2, 1, 2. When x equal to negative 2, which is right here, we got a 2, 1, 2. When x equal to 1, got a 5. 2, 3, 4, 5. So it would be right here. Again, when x equal to negative 3, we got a 5. So if we connect everything together, we got a graph like that. Again, this is the axis of symmetry, which corresponds to x equal to negative 1. Notice if you compare this graph and this graph, basically the graph shift upwards with 1, right? Which is exactly this with this. In other words, when we look at this form, we know the axis of symmetry is A, and this is shifted up if the B value is the positive value. Again, we can find another equation, say y equal to x squared plus 2x. We're going to graph this. How do we graph this? We basically can rewrite this as x plus 2x plus 1 subtract 1, because 1 subtract 1 equals 0. So it's equivalent to that. Again, the front part is going to be x plus 1 squared subtract 1. So again, this is corresponding to the table right here. Then the new x and y set, x, y, it will be the one value less than the corresponding y value right here. So for instance, when x equal to 1, y equal to 1 0 subtract 1 is negative 1. When x equal to 0, is 1 subtract 1 equal to 0. When x equal to negative 2, the y value is 1 subtract 1, 0. When x equal to 1, the y value will be 4 subtract 1, which is 3. And then when it's negative 3, it's equal to 3. Now let's graph this. Okay. So x equal to negative 1, this is x over y equal to negative 1, so it's right here. X equal to 0, y equal to, when x equal to 0, y equal to 0, it's right here. Now that doesn't make, that is not correct. So x plus 1 squared. Wait a second, let me do it again. So when x equal to negative 1, y would be 0 subtract 1, negative 1. When x equal to 0, y equal to 1, subtract 1, 0. When x equal to negative 2, will be 1 subtract 1 equal to 0. Oh, I'm sorry, my bad. When x equal to 1, y equal to 3. 1, 2, 3. When x equal to negative 3, which is 3, 1, 2, 3. So if we connect every point all together, we will get a new graph. Again, it is the same symmetry of axis, which is x equal to negative 1. And then notice you compare this graph with that graph, that basically that graph shifts downwards for 1 unit, right? So again, look at this. So when it's a positive number, means shift up. When or negative number, which means shift down. Again, for the k, basically you can use the same technique to try to test it. Indeed, you know, if it is the larger number right here, see, basically you stretch the graph. You can kind of consider put it up, put it like stretch it. But if you got a fraction right here, let's say if the k is 1 over 2, for instance, then basically is you compressed it, right? Again, I leave this as the exercise, so that way you can play around with this, so you will get a better idea. And then the last thing I want to tell you guys, so far our example is y equal to something, right? What if x equal to y squared, for instance? Then you will have something like that. X over y. Again, this is going to be touchstone region. Why? Because this basically tells you it doesn't matter whether you got a positive y value or negative y value. After you square it, it's always going to be the positive. It's right here. So that's why the thing is open to the right. On the other hand, if you have something like x equal to negative y squared, then you will have something like that. And then you can use the same thing that we discussed so far to try to shift the graph, more to the right or more to the left, and then whether it's stretched or compressed. So once you understand all those, you will have a pretty good understanding about quadratic equation. And that is the very practical polynomial equation, because later on when you learn physics, when you, for instance, when you throw a rock, the trajectory of the rock actually follows a quadratic equation. With that being said, good luck for your guys' test, and let me know if you have any further questions. Thank you. Bye-bye.